So we talked about photosynthesis. Now we're talking about a process called cellular respiration. It refers to a set of reactions and processes that take place in the cells of organisms, and it converts energy from plants and converts it into ATP, if you will. So if we get our energy, through our nutrients, and this is what allows us to actually get the ATP that gives us energy, quote unquote. You say food gives you energy, well, this is what we're actually kind of referring to. So cellular respiration, this is glucose plus oxygen produces carbon dioxide, water, and energy. So what do we notice about these equations? If you kind of think about it, when you look at this, they're kind of opposites of each other. Or not opposites, but they're flipped. So in photosynthesis, plants take up water, our carbon dioxide that we release. With light, they produce sugar and oxygen. And then in cellular respiration, it actually uses sugar, glucose, and oxygen to produce carbon dioxide, water, and energy. So cellular respiration, there are three main steps, and you should know the broad strokes of each. If this was a biochemistry class in college or whatever, you need to know all the different steps in glycolysis, in the Krebs cycle, and so that's what I did in college. So So glycolysis, lysis, that lysis part, I guess, is a breakdown of this. So glucose in the cytoplasm of the cell. No energy is used. Glycolysis is a totally anaerobic process, if you will. It produces two molecules of ATP. My bad. Something called pyruvate and NADH. So you kind of just have to not memorize this, but just kind of keep this in mind because these will pop up later on in the lecture. The Krebs cycle is anaerobic. It's anaerobic, so it's not anaerobic, but it's aerobic. And it actually, so this requires oxygen for it to happen. It occurs in the mitochondria. It takes pyruvic acid, or the pyruvate which we talked about before, and from here you actually produce ATP and other sources of energy. The electron transport chain, it's another aerobic process, and it also occurs in mitochondria. However, this step requires enzymes that act as carrier molecules and transfer molecules, which we talked about in chapter 4. What they do actually as enzymes and coenzymes, they accept electrons which contain energy and pass them in this kind of a chain-like reaction, if you will. The final electron acceptor is an oxygen atom. Boxing and starring. Hint, hint. It also produces 38 ATP. Box and starring. Hint, hint. And hint, hint. And hint, hint. And none of the one before. Hint, hint. So the end goal of aerobic respiration, excuse me, is 36 molecules of ATP. So if all your cells are doing this, you get a lot of energy. However, there may be an instance where respiration is occurring without oxygen. And this process is called fermentation, and it's using a hydrogen acceptor. But we're going to focus on that. So the first one is lactic acid fermentation. Pyruvate, or pyruvic acid, is converted to lactic acid. This occurs in animal cells, and you've heard of this term. You should have heard of this term already. So lactic acid fermentation. Y'all can see that GIF. I hope that's pretty intense, not gonna lie. So what is this? This is actually a leg cramp, Charlie horse, whatever you want to call it. It's pretty intense, not gonna lie. So what happens is when muscles operate without oxygen, this means that pyruvic acid is being used up because there's no oxygen. Blood removes normally removes excess lactate or lactic acid from muscles. If they're not removed quickly enough, this builds up. That leads to the cramps that you feel, especially after working out, because you're depleting that supply of oxygen in that area. And also, this is really quick, when people talk about lactic acid, well, sorry, no, they don't. When they talk about, like, if you have a heart attack or an MI, myocardial infarction, where their chest is hurting, when I say my chest hurts, what happens is that, say this is your heart, and then you have these main coronary arteries that looks nothing like a heart, but whatever, that supplies blood to the heart. Not like through the heart, but actually for the heart. So what happens is if you block one of these coronary arteries with a clot or like, you know, however you want to describe it, whenever it's plugged up, oxygen, blood is not being carried to the part right here, say for example. So that means that if there's no blood, there's no oxygen. So therefore, when there's no oxygen, you end up getting lactic acid fermentation, and it forms in that area because there's no oxygen. That's why the chest hurts, because the lactic acid is building up and it's hurting. Just FYI. So the last little bit of information, if you will, we're going to talk about is alcoholic fermentation. So this occurs in yeast. Lactic acid fermentation occurs in animal cells. So in this instance, so in yeast, pyruvate or pyruvic acid is actually broken down into ethanol or ethyl alcohol, and CO2 is released. So that means that whenever you, if somebody bakes, technically they are kind of producing ethanol alcohol when they're baking. The thing is, though, is that you don't really get drunk off of eating bread, because ethanol actually has excuse me, has a low boiling point. And so what happens is that when it reaches that temperature, it's going to burn off or boil off, I guess, and there's not really going to be any alcohol in the bread. So, like, let's say that, oh, I'm going to make some bourbon chicken, I guess. That's the thing. So putting bourbon on it, your uncle wants to do that. He's insisting he's going to get whatever after eating it. The thing is, you can tell me you know better, because you know that alcohol or ethanol, ethyl alcohol, has a low boiling point. Therefore, you can't get, whatever from eating that food that has the alcohol used for cooking, if you will. So, kind of a side effect of anaerobic metabolism, or the end result, I guess, it's not really a side effect, but it's that you only make 2 molecules of ATP with anaerobic metabolism. In aerobic, you made 36. So, I guess that's like a few takeaways you need to get from this lecture, at least. So, that is it for now. Hope you all enjoy the lecture, and be safe. Take care, and hit that like and subscribe. Bye.